Today, I'm supposed to be taking you through revision. I was instructed by one of my colleagues to basically start with the basics so that even those who had not covered this particular topic from their schools can also benefit. So allow me to start with a few basics that we need to know as we progress towards the last bit of vectors. Maybe without wasting a lot of time, first of all, we need to know what a vector is by definition. This is something that you've studied both in mathematics and in physics. So first of all, teachers could have told you that a vector is a quantity defined by both the magnitude and the direction. It must be defined by both the magnitude and direction. And after that, there are a few key terms that you must know before you get yourself to this topic and before you make yourself better. And one of them happens to be a column vector. A column vector. We need to know what a column vector is. Now, to briefly talk about a column vector, we are going to consider a point on a Cartesian plane. And that point, if I have a point, for example, a point xy, if I have a point xy on a Cartesian plane, when I talk about a Cartesian plane, I mean on the x and y axis. Then this point can be written as a column vector by simply writing it in the vector column form, as you see. Now, this is now considered to be a column vector, but these points that you see here are simply coordinates. These points are coordinates. A column vector for that particular point is written as xy. Then after that, you also need to know something about position vector. We need to know something about position vector. When I talk about a position vector, now we are going to be looking at a displacement from particularly the origin. We're going to be looking at a displacement from particularly the origin. For example, if I want to move from the origin, to another point, maybe to a point A. I want to move from the origin to a point A. And point A automatically maybe has coordinates. I can say x1 and y1. And then you must also know that origin, of course, must have coordinates 0, 0. Now, the vector that is obtained with the reference to the origin, that shows the motion from the origin to A, is written as OA. Now, when I say OA, I can indicate an arrow up, or I can write it as OA, then I indicate a tilde sign. To represent or to show us that we are moving from point O to point A. Now, this is what we consider as a position vector by simply denoting the abbreviation. But the definition now of this position vector will be written as x1, y1. You can write it as x1, y1 in form of a column vector. So this OA is a position vector of A. And so that clearly makes it come out to you. And you must know that when I talk about position vector, then we are talking about motion from particularly the origin to a given point. Motion from particularly the origin, a given point. So that is something you need to know about. Position vector. Then there is also another term. I will have to clear my screen because these are a few key points that your teachers might have talked about, but you can also take screenshots if you're sharp enough. You can take screenshots. Then I can talk about displacement vectors. Now, when I talk about displacement vectors, you must know and I'm now looking at 2 points. And I'm simply looking at motion from one point to another point. I'm going to give a simple example here. If I have point A, which is 1, 2, and point B, which is 8, 6. And I want to move particularly from point A, I want to go to point B. So the vector or the overall vector that shows the motion from A to B, which is written as AB, is going to be what we call the displacement vector. It's going to be what we call the displacement vector. I hope that is very clear. In case you have a question, please, I will always allow you to raise it. Without wasting a lot of time, I want us to go to the main point because we are here for revision. And I'm going to talk about particularly, yes, displacement vectors, but I'm going to borrow the idea from the vector geometry. Let us consider this triangle. Let's consider this triangle where O is the origin, A is a given point, and B is another given point. Now I want to consider motion from point A to point B, but I don't want to use a direct route. So I want to move from A to B, but I don't want to use a direct route. Automatically, I must first know what the position vector of this point is and what the position vector of this point is. Now, if the position vector of A is small a, we always include the tilde sign to represent it as a vector. Then the position vector of B is small b. We also write it like that. So if I want to move from A to B, I have two options. One of the options will be going directly, but I don't want to go directly this time around. So it means the only option I'll be having will be moving from A to O, then from O to B. That will be our kind of motion. And what does that mean? I will now say that if I'm to move from A to B, I'm going to indicate that arrow, or I can use a tilde sign. I told you earlier on that you can also represent it as this. I will say AB is equals to AO plus OB.
Okay, sorry, we have lost teacher Peter, but hope we'll get back here. Okay, so we are looking at vectors. Let me be sharing my screen as he gets back. Okay, good afternoon, everyone. Can you unmute and say something? Some of you are not saying anything.
Good afternoon.
Okay, good afternoon.
Sorry for the disconnection. Sorry for the disconnection. I earlier communicated that I have a lot of rain within this place.
Okay. Okay, teacher Peter.
Oh, yes.
Teacher Peter, are you set now? Seems I'm not seeing teacher Peter. Okay, okay. I think he's having some network issues, but when he gets back, so he has been explaining and talking about one of the key things, one of the key topics that we agreed on to start with, which was vectors. Teacher Peter, when you get back, you let me know. And one of the key things he has looked on has been what we call a vector. So there are important two things you should always know when they talk of a vector, be it in physics, be it math, and that is what we call a magnitude and what we call a scalar. So one of the activities I have for you, a tourist has arrived at Entebbe International Airport and is to visit the source of the Nile in Jinja Town. What two aspects of the journey must he know? Can we have some volunteers to tell us the answer? What two things? Imagine you are just a new person to the place. What do you think you need to know? Can someone give us a hint? Teacher Peter, are you back? Yes, Jed?
You should know the direction of Ginger from Entebbe.
Yes, you should know the direction of Jinja to Entebbe. Good. That is another aspect. Yes, Precious. Precious, go on. Oh, Precious, you are not talking. Manuela, go on.
The tourist needs to know how far is Jinja from Entebbe.
Perfect. Good. Yes. Those are the two things that he must be knowing. He must be knowing that this is how... Okay. Yes, he must be knowing how far is Jinja from Entebbe and what direction is he to use. So whenever you are locating, whenever you have a person, when you are telling him where you stay, never tell him that maybe, because most of you, when they ask you, maybe Precious, where do you stay? You tell him that I stay in maybe Kampala. So Kampala is very big. So you need to tell him that distance, and then you tell him, you tell the person and the direction. Okay, let me mute you. And that aspect is what we are looking on. That is the reason as to why we study these vectors, that we want you to learn that these vectors are really apply in your life. Those are the things you have been seeing. Okay. Teacher Peter, you can continue. Hope now you are settled.
I am, but I have that interruption of the rain with the network. So thank you for coming in. We have a lot of rain where I am. And you know how our network in Uganda is always interrupted, but let me try my best. Again. Okay, so I thank you guys for the patience. I was just talking about this. I was talking about some small brief information about the coordinate, the vector geometry. And I was trying to tell you how we can move from A to B. Now, to add on a little bit, from AO, you're going to realize we are moving in the opposite direction as to the one indicated here. So because of that opposite direction, we shall indicate this as negative of A. Negative of A, then plus OB. When you look at this, it's as good as getting OB now minus OA. Minus OA. But OB, as you get back to the diagram, you realize its position vector is small b, and OA has a position vector small a. I hope you guys can see me because I have rain.
Yes, but why do we have to interchange?
Okay, good. So now I want you to get it clearly. This is very important to note, and knowing that our small b represents the position vector of b and small a represents the position vector of a. Apart from only knowing this, you must also know that indeed, if I have a b, it is always as good as the OB minus OA. So what is the order? The order is that you take the position vector of the last letter minus the position vector of the first letter. That is the right order. Now, from this basic knowledge, we are going to learn how to do some small questions, a few questions in form of revision. And one of them can be this. Let me call them examples. Number one, given that the points A and B have position vectors, OA equals to 2, 3, and OB equals to 3, 4. Let me take that. They can ask you to find, for example, vector AB. They can as well ask you to find vector BA, and then later we shall look at how we can find the magnitude of each of them. They can ask you to find the magnitude of vector AB, or what we call the length, magnitude or the length. Now, from my simple explanations, for us to get vector AB, we must know that we get the position vector of the last letter or the last point minus the position vector of the first point. And that means we shall simply substitute for OB, and you realize that OB is 3, 4, and OA is 2, 3. When you do this subtraction, 3 minus 2 will give us 1. 4 minus 3 will give us 1 also. So it means our vector AB is going to be 1, 1. You leave it in vector form. Roman 2, they ask us to get vector BA. Vector BA, which is given by OA minus OB. I told you the order is get the position vector of the last letter minus the position vector of the previous or the first. Now OA is given us 2, 3. We are subtracting OB, which is 3, 4. When you do the subtraction, you're going to get -1, -1. Now, what is the relationship between vector AB and vector BA when you check out here? Now, we realize that vector BA, this is BA, I beg your pardon, this is BA, this is vector BA. We realize that vector BA is a negative of vector AB. Why? Because you see we have negative, negative, and then positive, positive of the same coordinates. Then when you come to Roman 3, they want us to get the magnitude of AB. Magnitude of AB, you're going to simply remember the formula, which says you take the square root of the x coordinate squared plus the y coordinate squared. This is our formula for getting the magnitude or the length of a given vector. So we get 1 squared plus 1 squared. And 1 squared is 1 plus 1 squared, which is 1. That gives us root 2. Or someone can write it in decimals. but for at least 4 DPs, unless instructed otherwise. Unless instructed otherwise. So you must know that clearly. You must know that clearly, that you can write your answer also to decimal places, but make sure at least you write to 4 DPs. Yeah, of course, they don't penalize you if you write to 2, 3, but 4 are better unless otherwise. Unless otherwise. So can I have any question about this so far? In case there's a question about this, in case there's a question about this, please. Hello. Or have we followed this example very well?
Yes.
No.
Yes, teacher.
Since we are many, it will take us long to respond to that. But in case you have a question, please, you have an option of raising the hand. I will see and then get back to you. So, a question. Take a screenshot quickly, then I move on. Okay, Precious, I see your hand up. Precious, I see your hand up. You can speak out. Yes, Precious.
Sir, that's where my mom is.
Sorry?
My is about magnitude.
I can't hear you well. I can hear you about magnitude. Oh my God.
Yes, please.
I think you have a network issue also. I'm experiencing a challenge hearing what you're saying, but as if you're talking about the magnitude and you're asking whether that is the answer, I say for the magnitude, as long as you've reached this point, you can opt to press a calculator. You can opt to press a calculator, and we use the formula. Remember, we say length of a given vector. Length of a given vector is given by the formula square root of x squared plus y squared. So Precious, I didn't get you very well, Precious, but I guess you were asking about magnitude. I say you can write the answer there. My interest is to give you the concepts, then you write the answer there. Allow me to proceed to the next question, unless there's some other question. If there's another question, please ask. Now, question two. Question two. They can choose to give you. They can choose to give you a combined vector. They can choose to give you vector AB. They tell you vector AB is equals to, can I say 5, 6? And they give you another vector, particularly, for example, OA. They tell you OA is equals to, let me say, -1, 2. Then they ask you to find Roman 1, vector OB, and then Roman 2, maybe magnitude of OB. Please, they can write the name. And in your question papers in your name, when they don't put the arrows, then they make sure these letters are bold letters. They are bold, so they appear to be a little bit dark compared to the other letters or other words. Now, what would we do in this particular case? First of all, to get OB, you must realize that B
Okay. It seems the network is not favoring. I think I'm going to take over from there. His network is not favoring him. Okay. So I think, do I need to go back this side, or should we just continue from where he has ended?
Yes.
Teacher.
Yes.
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 Okay.
Yeah.
Okay.
Yeah.
Okay. 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 So you talked about all these. Number one, what I want you also to learn. Okay, let me start from here. I want to emphasize some few things. Is what we call a position vector. Whenever they talk of a position vector, is that one that starts from the origin. Its starting point is always 0. So it starts from origin and then it goes on. So these vectors, when you look at A, this is a vector. So to write it as a position vector, I write it as OA. So OA, in case I want to write it, I can still go and write it in terms of a column vector. So in case it is given to you maybe in form of a graph and you want to read it, that means you just count how many units do you have. I have 1, 2, 3. So always the first one is your X and then the second one is your Y. So I write it as 3. Then when I look at the vertical is 1, 2, 3. So also the vertical is 3. So this is how we write a position vector. So always the position vector starts with O and then you have another letter. So he has talked about that. Then another thing is that at times they give you your code, they give you a coordinate. Whenever you find a comma in an horizontal format, this is a coordinate. So you will always be asked to write it in terms of a vector. So when you are writing it in terms of a vector, in terms of a position vector, always I will say 0A, and then now I can write it as 2, 3. Is that fine?
Yes.
Yes. So in case it is B, I write my vector as O to B, then I write it as -6 and 8. So always pay attention when it comes to a position vector. So, but I want to go straight where he had ended. So we can have this as one of our examples. So they are telling us that they have given us a vector OA and OB. So always when we are representing vectors, we can use bold letters. So when you find a bold letter, that is a vector. When you find an arrow above, that one is also a vector. So in case I want to find my vector, column vector AB, the teacher has already told us that when I have my vector AB, you remember, he has told you that now when you look at O and OB, that one shows you it is a position vector. So in case I have my vector A and B, and I want to find out what is A to B, always pay attention to these letters. The first letter always shows you the starting point, where you start from and where you end, meaning that your arrow starts from A and goes towards B, meaning that our arrow will be pointing from A going towards B. So that's how the arrow will. When I have O to A, it means I start from O and then I go towards A. So my arrow will be like that. When I have O to B, I will start from O, then I go towards B. So that is how you must move. So in case I want to find my column vector AB, what does it mean? It means that A to B, the path I can use, you ask yourself, which route can I use to get to B? How can I move from A and then I go towards B? Vector is about movements. It means I can start from A, I go towards O, then from O, I go where B is. So our AB is the same as having A to O, then plus O to B. But when you look at A to O, AO, we are moving in an opposite direction to the original one. So when I have my vector A to O, this is the same as having negative O to A. Hope this is clear. That whenever I change the vectors, I interchange, I put a negative. So this negative shows us a divergence in the direction. So here we shall have negative OA plus OB. And this one is where, when you want it, you can write it now in a better way, that you start with O raised to positive, OB minus OA. So if at all you want to find our column vector A to B, then it means I'll have my O to B, then minus O to A. Are we together?
Yes.
Okay, so our column vector O to B is 5, 7, minus my column vector O to A, which is 2, 4. So when we are subtracting two vectors, we subtract corresponding ones, x and x, y and y. So here we shall have the 5 minus 2, then we shall have the 7 minus 4. And therefore, we shall have our vector equaling to 5 minus 2, what do you get?
3.
3. 7 minus 4?
3.
3. Good. So meaning our vector A to B will be that. Have we understood?
Yes. So, teacher, it's not that we can't go directly through AB. It's just that we don't have AB, and that's the way we find it.
Yes, exactly. Exactly. Okay. Yes, William, you have a question?
Can't we simplify it more like we get 1, 1, 1?
1, 1? No. What now you want to do is when you factor out, but that one, this is how far you can go. You cannot simplify it any further. This is a vector, so you are not dividing. Don't confuse it with dividing. So I think, William, you're trying to divide it. No, we don't divide like that. So those are two different components. Are we together?
Yes.
Okay. Mr. Peter, are you back?
Yeah, I'm back, and my power is now back, but rain is too much.
Oh.
Very sorry for this, my brother. Yes.
So should we continue or you come back?
I have no problem, but what maybe I could do is, since you're kicked off, you could continue with them. Then maybe some other time when I'm very stable, when all the conditions around me are very stable, because these connections are not good.
Oh, sorry.
Yeah.
Oh. Okay. Let us push on a bit.
Otherwise, thank you for coming in immediately.
Okay, so we can look at operations of vectors. So operations are, those are the mathematical, we have 4 of them. We have the addition, we have the subtraction, we have the division, and we have the multiplication. So what happens when you are adding vectors? Whenever you have any 2 given vectors and you are adding them, always add the corresponding components. Take an example. In case I have okay, sorry. Okay. Oh, okay, sorry. Is my screen back?
Yes.
Okay, so when I have 2 vectors, I have 4, 2, and I have my D equals to 5, 4. So when you are adding vector C plus D, always add the corresponding one. The 4 can only be added with 5, and can only be added with 4. So you add the corresponding ones. Never add, you add, this is, remember the first one always in column form. The first one is always X, and then the second digit is Y. So you only add the X and the X, the Y and the Y. You have that one at the back of your mind. So allow me to use this one. Okay. Can we now try out? Tell me the answer. What will be our vector A plus B? What is our vector A plus B? Can we still use the chart?
It is a 7 and a 10.
It is? Is everyone
7 and 10.
7 and 10? Very good. Okay. Then now when it comes to subtraction, still the same thing. Always subtract corresponding components. Someone is having a poor background. Okay, so always, even when it comes to subtraction, we still do the same thing. We subtract corresponding components. Let me ask you to do for me this one.
-1. Negative.
Okay. What are you getting?
-1, -2.
-1, -2. Good. Perfect. This one is a sign that you are understanding. So we are going through the vectors a bit quick. Then another one is what we call a scalar. A scalar is just a number that multiplies a vector. So it can take an example. When I have my vector, say I have my vector A is equal to 3, 4, and they want me to get 3A. So this number that is accompanying a vector is what we call a scalar. So what does a scalar do? A scalar is something that can make something bigger or it makes it smaller. So to take an example, you can be a bit, it can magnify it or enlarges it, and at the same time, it can make it very, very small. That is something like what we call a scalar. So a scalar is just any number that we have that can multiply a vector. So when I have 3 and A, this number that is multiplying my vector, it affects both the X component and the Y component. So when I'm multiplying this 3, I will always multiply by the X. I get this 3, I multiply it times that X component. This same 3 multiplies the what? The Y component. Meaning when I multiply, I'll say 3 times 3. Then the same 3 will multiply the number that we have in the Y position. So then you get your final answer as 9, and then you get your answer as 12. Is that fine? Scalar multiplication?
Yes.
Okay.
Yes.
Okay. Okay. So this is what I was telling you, that a scalar can make something big. So in case I have, this is my vector A, when I multiply it by 2, it becomes bigger. And now in case even at times even it can be negative A. So this one, there is a -1 hidden here. So in case I have -1A, this one instead it changes the direction. In case our vector A was going like this, when I have -A, the direction will change and will look like that. So that is the effect of a scalar. Okay. Yes?
Yes.
Okay. Can you do for me these parts? Part A. Feel free to say in the chat.
8 and 12.
8 and 12. Is everyone coming up with 8 and 12?
Yes.
Good. Part B.
4, 2
and 3.
2 and 3. Beautiful. Is everyone coming up with 2 and 3?
Yes.
Okay. Good. Can we do part C? Do you want to try it?
Yes.
Yes?
Yes.
Okay, good. First get what your 2A is, then find out what is 3B. So find out what is 2A. Yes, please. Yes, please.
How do you guys got 2 and 3 or 3? They have A.
Your network is not good. Your network, Precious, is not good. Type in the chat. Type in the chat. Your network is not good. So have we gotten the answer for part C?
Yes, teacher.
Okay. Is
14.
I get 8, 12 here for 2A.
Yes.
Then
Yes.
for 3B, what do you have?
6 and -9.
Negative. Does everyone have those answers? Have that step?
Yes.
Okay. So we can go on now and add. So we have 8 plus 6.
14.
12 plus -9.
3. Positive 3.
Positive 3. So this is our final answer. Hope everyone is there. Anyone we are leaving behind? Okay, good.
No.
Okay. So these are section A numbers. These are section A numbers. Okay. We are not going to do this. We are not going to do it. We are not going to do this activity, but this one was I wanted to show you something, but we are not going to do it. Then we have what we call the magnitude. So there are 3 words they can use. They can say magnitude, they can say modulus, they can say length. Whenever you hear that word, be it even in coordinate geometry, never get confused. They're asking you to find the length. Take an example. Most of you have noticed at school, we have what we call shortcuts. I don't know that you have noticed. You find a school whereby this is the office, maybe this is where our office is, and you find that there is a class maybe here, but always you find someone walking like this and then has to go like this. Yet there is what? A shorter route you can use directly. And always if at all you go to schools, you find that even they have planted there now grass, they are putting there trees to not allow people to use them. And always these shortcuts are discovered by students. So these kind of shortcuts is what we shall be calling the magnitude. So the length from here up to here is what you call the magnitude. So always a modulus or length or magnitude is just the length, is the distance between those 2 given points, but in a shorter format. So in order for us to find the length or to find always our magnitude, always you look at what we call the Pythagoras theorem. So along this one is where we have our x component, and this is what we call our y component. So in case this is my z, always you know from Pythagoras theorem that to get this hypotenuse, this distance here, I will have z squared equaling to x squared plus y squared. To remove the square root, to remove this squared, I'll get the square root on both sides. I get a square root, I get a square root. So I'll have my z equaling to square root of x squared plus y squared. So this is what you call the magnitude, or what you call the length that exists between the 2 points. So whenever they ask for magnitude, modulus, length of any vector, just get the x component squared plus the y component squared. At times, in case they don't use words, they use these 2 bars. They will say this. So still when you find these 2 bars, they're asking for the magnitude. Okay. Should we try out a number? Okay.
Yes.
Oh, okay. Can everyone do part A first?
Yes.
Okay, let's start with part A.
Five.
5. Some people are getting 5. What about the rest? Type in the chat. Type in the chat. Some are getting 5. I don't know what the rest are getting.
5.
5, good. Anyone not getting 5? Everyone is getting 5? Good. Lena is saying us 5. Loda, Judy, William. This is good. John is also getting 5. Good. Okay. Those who have finished, let's work on part B. So when it comes to part B, first work out what is inside the magnitude. First work out this. find out what is my A minus B. After doing so, go on and get the magnitude.
Square root of 2.
Square root of 2. Okay, I don't know the rest what they are getting. So type in the chat. Type in the chat what you are getting. But please don't leave your answer in a square root format. You can simplify unless you have been told to do so. So write and write to at least 4 decimal places. Okay.
So it's 2.
The answer is 2. Lona is saying it is 2. Ben is saying it is 2. Lena is saying it is 2. William is saying 2. Someone was telling us square root of 2. Okay. So is the answer 2? Are we seeing how?
Yes.
Okay, good.
Yeah.
Okay, good. In case we are leaving you, please let us know. Can we go to part C? In case we are leaving you, tell us and we help you. Tell us and we help you.
Teacher, could you repeat how we find the magnitude?
Okay, the magnitude. Now to find the magnitude, you have said, in case I want to get the magnitude of A, I'm going to just get the square root of x squared plus the y squared. So always whenever we are writing a vector, they write it in form of x and y component. So your x is always that value up. Then the y is the one down in the second position. So meaning we shall have square root of 3 squared plus 4 squared. So you go on and simplify. 3 squared is 9 plus 4 squared, which is 16. So this one will end up giving you root of 25, which is the same as 5 units. So when it comes to A minus B, first find out what is A minus B. So we have looked at how we subtract vectors. I will say my A is 3, 4 minus my B, which is 3, 6. So when you substitute, you have 3 minus 3 is 0. 4 minus 6 is what? Negative 2. So afterwards, after getting this simplified answer, you go and get the magnitude. So still you go, you get the square root of x squared plus y squared. So I'll have my 0 squared plus negative 2 squared. But negative 2 squared is what? Is the 4, then plus 0, which is 4. So I have my square root of 4, which ends up with a 2. Have you understood?
Yes.
Okay.
Yes.
Okay. I'm waiting. Patsy.
Teacher, I've got 26.83 units. Or the square root of 720.
Okay. Let me wait. People are getting different answers. People have got 6. 26.8.
I think it's 37.95.
Let me see.
That's 7.95.
9. Okay. Let us see which answer is dominating. That's what we shall go with now. So let me start. Lena is telling us 26.8. William is telling us 26. Judith 26. Lona 26. Denies 26. Is everyone coming up with 26? Jasmine 26.8. It seems 26.8 is the answer. The person who was getting 6, have you discovered your mistake? Blessing, Huntington, Monica. Have you discovered your mistake? Let us know and we see whether you are there. 26.8, okay, lol. Nanila 26, Blessing 26. Seems 26 is the answer. True?
True.
Okay.
Yes.
Okay. Anyone who needs help, or we move on? We move
Teacher?
on? Yes.
The one part C, the magnitude of 4.
Okay, have you got your 4B?
Not yet.
Okay, tell us what is your 4B?
I have not yet got my 4B.
Okay. Okay. So can you, but have you written the question down?
Yes.
So you get it and you tell us whether, and you're going to be telling us whether you have got the same as 26.8.
Okay.
Okay, here we are not going to plot. Okay. Is this one fine? Should we leave it?
Yeah, we leave it.
Yes.
Okay, but first do part A. There is a mistake I want to discover.
C.
There's something. Do part A at least. There is something you are going to discover that we might get different answers. So these are some of the section in numbers. Let me see, someone might have even given us the answer already. Good, good. You people, you are very bright, very, very bright. Yeah. Yes. Here, what is the biggest mistake people do? The biggest mistake usually students do comes here. They say -3 squared plus 4 squared. So you find someone writing the answer as -9 plus 16. So this is one of the biggest mistake that usually candidates do. So this is what I thought I could get, but you have surprised me that everyone at least knows the trick. Okay, thank you everyone. Yes, the answer is 5. Good. This one we have to try it. So they have given us the two vectors A and B. Find a column vector AB. You want to first try it?
Yes.
Okay. Okay. Yes. Let's first try it. But the first thing always you have to do is you have to write this coordinate in form of a vector. Write this coordinate in form of a vector. And I told you that here we are going to be dealing with what we call position vectors. So meaning I'll write my OA as 2, 2. Let me stop there. Write B and then find out. So the rest, let me allow you to find out. People have already even gotten the answer. This is so good. People have the answer already. Blessing, Beyond, Alena, Lona, Lina. Good. This is beautiful. So the answer you're getting, can everyone confirm whether you are getting your vector, column vector? So when they tell you column, you must write it in a column way. So your answer is 4, 2. Is everyone coming up with that? Let me. So the chat is the one telling, wow, wow, Goletti, User, Stephanie, Yoni, Nanila, Oklol, Jasmine, Judith, Blessing. Wow, this is very good. Very, very good.
Teacher, can you work it out?
Yes, you are saying?
Help work out that one.
Okay, Karen is saying, okay, so Karen, our vector ought to be is going to be 6, 4. So Karen, how would you get column vector AB? Do you know the definition?
OA plus OB.
What? I beg your pardon?
OA plus column vector OB.
Oh, Kellen, now this is where your mistake. This is where you are making a mistake. Kellen, remember I told you that when you have vector A and B, and this is O, to go from A to B, you use this direction. But this is OA, this is OB. So A to O is always in reverse order. So Kellen, from today onwards, this one is not right. always it is the OB minus OA. Karen, I don't know that you're getting it. This is where you're making the mistake. Is this fine, Karen?
Yes.
Okay, Karen, now surprise me. Tell me, what if you have PQ? What will be your definition?
OQ minus OP.
Perfect. What if you have MN? What will be your definition?
OM minus OM.
Ah, I beg your pardon?
ON minus OM.
So always the second letter is the first minus the first one. Okay, so Karen, find out whether that is right. Okay, good. Can we also try this? Okay, can we also work out this? So here, definition is key. Knowing the definition of a displacement vector. So PQ, whenever you find those vectors without O, we call them displacement vectors. When you find the one which has O, we call it a position vector. Okay, so you should also note that one somewhere, that this one is what we call a position vector. This one with the two letters, we call it, with two different letters, we call it a displacement vector. Okay, someone giving us. Okay. So people hope we were writing. Denise. Oh, the number with R. Denise, can you unmute? I'm not getting you. Which number could that be? Denise, unmute. Oh.
The number with magnitude of 2R.
Okay, Denise, allow me to do it here. So you had our R as -3, 4. Okay, Denise, can you take us through how we get the magnitude of R?
Square root, open bracket, -3 squared, plus, in brackets, 4 squared.
Continue.
Equals to square root of 9 plus 16.
Okay, continue.
Which is equals to a square root of 25.
Equaling to,
which is equals to 5 units.
5 units. So which part do you want? We had the part of this nature.
And the other one of 2R.
So this one, what are you going to do?
I was going to multiply 2 times 5 units.
Perfect. And your answer becomes?
10 units.
10 units. Good. Then the other one, which had 2R, what were you going to do?
I would multiply the 25 times 2.
Oh, no. Oh, now Denise, this is 2R. So you have to first multiply 2 times R. Do you know our vector R is -3 and 4. So you have to first get 2R. So can you first get what is 2R?
It's -6. 8.
8. Then this is what you use to get the answer. Is it fine?
Yes.
Yeah. Okay.
Thank you.
Okay. So hopefully we are here now. I'm seeing very many answers coming in the chat, but there, Monica is telling us. Yes.
Teacher, for me, I have 7 and 5.
7, 5, -3, 7. -3, -5. So here we have differing answers. let us work it as a class also. Work it and see who is right and who is not. So who's going to first tell us how do we define PQ? How do we get PQ?
OQ minus O.
OQ minus OP. Good. So what do we want? We want to get OQ. So we have to make OQ the subject of the formula. Would you allow me to first take this negative OP away and I remain with OQ? Would that be fine? So I will say PQ plus OP is equal to OQ. Then this is minus OP plus OP. But these two are going to reduce. So I remain with my OQ is the same as PQ plus OP. Is that step fine to everyone?
Yeah.
So our PQ is 26 plus OP, which is negative 5, 1. So when we add, tell me, what do we get? 2 plus negative 5?
Negative 3.
Negative 3. 6 plus 1?
7.
7. 7. Hey, people of negative 3, 7 are very right. So, Judy, it was Judy. Williams, hope now you have seen your mistake. Shaddai? Yes. Okay, hopefully also Jasmine, you have seen Shaddai. Okay, are we good to continue? Is everyone okay?
Yes, sir.
Okay.
Yeah.
Okay. No. Okay. We have another one. So now we are on section A numbers. These are section A numbers. And then we still have time. We are going to go through section B, but after mastering the section A. So meaning that any number you look at in section A, you must be able to crush it. Just know those are 4 marks already. Okay, so let's work out.
Yes, this amount. And that what it's going. Okay.
Okay, hope we are working out. Negative 4. Okay, Lena is giving us Joed. It's giving, oh wow, blessing. I'm seeing negative 4, negative 12, negative 4, negative 12. So for you, if at all you get something different, you tell us. Okay.
No. When it down.
Shaddai, Your background is a bit noisy. Let me mute you. Okay. Everyone is getting, wow, okay. I'm seeing -4, -12, -4, -2, okay, good. So in case you are not getting that, please let us know and we'll help you. But since many people are getting that, can I choose randomly? Let me see who has not said anything. Anita, have you said anything in the class today? Anita? Anita? Anita is not unmuting.
Yes, teacher.
Okay, Anita, tell us, how are you getting FG?
You're getting OF minus OG.
Oh, tell us again. How are you getting FG?
You're getting OF minus OG.
Anita, not really. Change a bit.
OG minus OF.
OG minus OF. Continue. What is your OG?
It's -1, -4.
Good. Minus OF?
3 and 8.
3 and 8. Continue. What shall we have?
We shall have -4. -12.
Good, good. So Anita, please pay attention here. At first, you are telling us something. Let me choose another one also to take us through part 2. George, you have not said anything in class. George, unmute. George?
Yes, good morning.
Yes, George, good afternoon. Okay, George, tell us how are you getting the magnitude here, FG?
Magnitude of FG, that will be FG equal to square root, open square root. That is the, what's this? -4 squared plus -12 squared.
Okay, continue.
Then that will give us 4 squared is equal to 16 plus 12 squared shall be 144.
Continue.
144 plus 16 is 160. Then the square root of 160 shall be 12.649.
Okay, good. Okay, thank you, George. I'm choosing randomly. Okay. Nicole, Lapula Nicole. Nicole, unmute. Nicole? Is Nicole? Yes, Nicole.
Yes, teacher.
Tell us, how are you getting GF?
OF minus OG.
Perfect. Continue.
38. Minus -1, -4.
Good. Continue.
412 is the answer.
412. Okay. Thank you, Nicole. Then the last one, Mark. Okay, Mark Calvin, Glory. Is this the Mark I know? Mark Calvin?
Yes, please. Good afternoon, sir.
Okay, good afternoon, Mark. Mark, tell us how you are getting the magnitude of GF.
Sir, I'm sorry, I've just arrived, but I'm copying up.
Oh, okay. But can you tell us, were you there when we were covering the magnitude?
No, this is my first lesson this time.
Oh, okay. Okay, Mark, let me have someone to help us. Maima. Oh, William. William, let us have William. Okirol William. O'Clore William. O'Clore William.
Yes, sir.
Okay, O'Clore,
Yes, sir.
tell us, how are you getting the magnitude?
We shall use the answer we got from this. We use 4. 4 squared. 4 squared plus 12 squared.
Okay. Which is equal to?
16 plus 144. Which will give us 160.
Okay. And then our final answer becomes?
12.649.
Okay,
units.
good. Okay. Just let me just do a quick review for those who have just joined in. Just a minute.
Excuse me, teacher.
Yes, please.
Teacher, what if I leave it on 160? I say 160 units.
Okay. Now, when that one will not be correct because you have not given the final answer. So always, unless they have told that leave it in a square root form. But if at all they have not told you to leave in a square root form, you have not simplified. So when you leave it in root of 160, you have not simplified. Hope that is fine. So you continue and give it. So in case the examiner wants it in a root, you will mark. But in case he wants it in points, then you have to mark the final answer. But always we mark the last answer. This is what is mainly, we are mainly interested. When you find root of 60, an ordinary person will not know what root of 160 is. But if at all you have simplified it to 12.649, this one is easy for someone to understand. Just imagine you are going somewhere and someone tells you the distance you are remaining with is root of 150. It will become a bit hard for you to understand unless now you need a calculator. So that's why we always encourage you to simplify it further. Hope it is fine.
Excuse me, sir, I'm just asking, why don't we use OF instead of OG to subtract OF?
Okay, like I've said, those were okay. I'm saying, let me just a quick one, please, members. Those who have just joined in, let me just give them just a hint. So we have said that when I have two vectors, this is 0. 0 is the origin, is the starting point. This is A and this is B. When I have O to A, that is my direction. When I say O to B, that is my direction. In vectors, always pay attention to the first letter. The first letter shows you the starting point, and the second letter shows you the final point. So O to A means I start from O, I go to A. When I write Kampala, Entebbe, this one is in vectors means I must start from Kampala, I go towards Entebbe. When I write Entebbe to Kampala, it means I start from Entebbe, I go towards Kampala. So here, what is important is direction. Direction is paramount. When I say O to B, it means I start from O, I go towards B. When I say A to B, it means I start from A, I go towards B. So here, in case I want to get my vector A to B, AB is what we call a displacement vector. A displacement vector is one that is expressed in terms of a position vector. A position vector, whenever you see O and a letter, that one qualifies to be called a position vector because it is starting from the origin. So O to A is a position vector, O to B is a position vector. When I have A to B, A to B is a displacement vector. So in case you want to move from A to B, when I want to move from A to B, it means I start from A, I look out for the route I can use because we don't know A to B, but I can find O to A and O B. So always find out for that route you can use. A to B, I can move from A, I come towards O, then from O, I come where B is. I'm finding out what is it from A to B. So that means A to B, I move from A, I come towards O, then plus O to B. But here, when I say A to O, it means that I have opposed the direction. And in vectors, when you oppose the direction, we use a negative. So a negative shows that you have changed the direction. So when I change the direction, it means I'll have, instead of starting from A to O, I will instead start from O to A. So I have negative O to A. So where I have here my A to O, I'll have negative O to A, then plus O to B. But in mathematics, it is usually good. You write a positive then, and then you write a negative. Imagine you are getting your report and you go back home when your report is saying that, let me use Mark. That Mark is very stubborn. He doesn't do work. That one shows a negative comment. So always in mathematics, we want always to start with a positive way, and then we bring the negative things later. So I want to first hear something positive, then I hear the negative can come on a bit later. So that's why always we say, begin with your O to B because it is a positive. Then this negative one can come in a bit later. So I write O to A. So whenever you have a displacement vector A to B, always this second letter is the one you start with, OB, then minus A. In case I have P to Q, I will start with Q first. I say OQ minus OP. In case I have M to N, I will start with N first, O to N minus O to M. In case I have CD, I will start with D. I say OD minus OC. When they ask for magnitude, let me use magnitude. In case this is my triangle here, and they're asking for magnitude, this is, let me say this is 3 and 4. Magnitude, and this is, let me say this is O, this is A, and this is B. Magnitude is like, magnitude is the distance that gives you the shortest route. So meaning that when I want to move directly from O to A, what is this distance? So here we apply the Pythagorean theorem. So I'll have this, to get in Pythagorean theorem, you know this is A, this is B, and this is C. So I will say C squared is equal to A squared plus B squared. But here our A is the one that is standing for X, and our B stands for Y. So that's why where there is X, A, I put X squared plus B, which is Y squared, is equal to C squared. So then I can get the root later on. So C is equal to root of X squared plus Y squared. So whenever you have a vector and they ask you to get modulus, get length, get magnitude, at times we use this one. These two, we put a letter, maybe a B. This one stands for magnitude, stands for modulus, stands for length. And always your vector, whenever I'm writing my vector, I write it in this format. So this is what we call a column format. Column, this is a log looks like this, and then a column is the vertical. So whenever you write a vector, always you want to work out in a column form, and always the first one stands for X, the second one stands for the Y component. So X, those are the, like in case I have my coordinate 2, 4. So X is this one, so I write it as 2, and Y is 4, I write it like that. Okay. Hope now most of you are on the same page. Okay. Okay. So let us work out quickly this one. Or it is easy, we can leave it. What do you think? Should we leave it or we can try it?
Let's try it.
Okay. So let's try it. Okay. Oh. Look. Sorry.
1 -8.
Okay, 1 -8. Good. This is beautiful. Okay, let's go to part B. Hope everyone is there. Okay, 1, 2, 1. Oh, part B. Okay. Hey, part B. I'm seeing someone telling us 0.5. Someone is telling us 0.5. We need to check out. Stephen is telling us -1. What are we getting? Part B seems people are getting different answers. Seems people are getting different answers. Does it mean we need to do it together? Yes?
Yes.
So what do they want? They want us to find x. For me, what I can do, the quick one I can do, I can first make x the subject. So I'll say 2x is equal to b minus a. Is that fine? Then I want x. I'll say my x is equal to, I divide b minus a, but all of it I divide by 2, I divide by 2. So meaning that it is the same as having a half b minus a half a. This is one option. Another person who wants, he can say, I'm going to have my x is equal to 1 out of 2 b minus a. So all of them are the same. So which one should we use? Another person could as well say, for me, let me first find out what is b minus a. So what is your b minus a? What are you getting for b minus a? Are you getting 1 and -8?
Yes.
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 So our next task is to divide by 2. So dividing by 2, I say divide by 2. I divide by 2. So what does it mean? It means x is equal to, so this 2 divides both numbers. I say 1 divided by 2, -8 divided by 2. And this one will actually give you your answer as, will give you x is equal to, I've seen people writing a half or 0.5 and -4. So this is your answer. So in case those who have written 0.5 and -4, you are very right. Okay. Are we good to continue?
Yes.
Yes.
So we take out the -16 win. Okay. So this is the exercise, but I think, don't you think we shall do it later?
Yeah.
Or we want to take screenshots?
Yeah.
Or I will send. I will do both. I will send, don't worry. To try out to test yourself. To test yourself. I want now to look at some vectors. Can you first do for me this part? Can we first do all of us this one? Okay, does it mean people have finished? Oh, Agimo, I don't know where the challenge is. I'm saying no. 18, 24. Munanira, read the question very well. Munanira, read the question very well. Something is missing. Read the question very well.
Eighteen 24.
Not really. I'm saying, someone is at least, Huntington, that is good. Lona, that is good. Ben, that is good. Lena, yes. Munanira, now you are back. Are we people seeing our mistake?
Yes.
Yes. Okay, good, good. Hope everyone is getting that 30. Yeah. Yeah. So they told you find the length. So we said length is magnitude. So people we are not looking at that part, but this is good. Okay. Okay. Anyone finding some challenges? Anyone finding challenges? Okay, good. Now we are going, this is the, we call it the gist. This is what is important. So what we have been looking on is mainly section A numbers. Now we are going to look at section B part, but still we are going to go in steps. So the first one is what we call vector geometry. So like we have said that here we use what we call the law of addition of vectors. The other one that I've been explaining. So, but we are going to start from here. I think this is where most of you wanted. So when you look at, we have in a triangle O, A, B below, O is that, B is that. They want us to express these vectors in terms of A and B. What am I going to do? Here, you must be very careful with the path, with the loops. Do not cram, but I want you to understand. Like I've told you, when I write A to B, AB means I start from A, I move towards B. Is that fine? So we want to say, this is what we are looking for, A to B. May I ask people to tell me, if I want to move from A to B, which path can I use? Tell me, how can I move from A and I reach B? Someone to tell us. I want you to understand.
AO plus OB.
Plus OB. Excellent. A to O plus O to B. Is everyone seeing that route? I want to confirm.
Yes.
Good. So you move from A to O, then you go to O to B. But now you ask yourself, what have I been given? A to O, you are not seeing that this one, they have given us O to A is A, and it is pointing this side, but for you are moving in opposite direction, meaning that now, since you are moving in opposite direction, you cannot write A, because A to O is represented by A. So meaning our A to O will do what?
Negative A.
Negative A. Is everyone seeing that?
Yes.
Then plus. Then what is O to B?
Positive.
Positive B. Very good. So in case you want here, then you can write it as minus B. So this is our vector A. Has everyone understood that part?
Yes, teacher.
Good. So now we are going to the next one. The next one is telling us to find A to C. But always I want you to read the question. Yes, Monica, first ask. Monica, ask. Monica. Oh, Monica, I'm not getting you. Okay. Now the next one.
Excuse me, sir.
Yes, please.
Excuse me, sir. Are you getting me now?
Yes.
I was asking here on AB, why didn't we say OB plus minus OA?
Yes, it is the same, Monica. Monica, it is the same.
Okay.
Yeah, but like
Okay.
what I want you now here, like when it comes to these ones, I want you to learn how to derive them, how to come to that answer, not just like a, so that's what I want. Okay, I'm seeing another hand. Yes, ask. Who's this? Help schools. Help schools, ask. Okay, help school is not asking. Okay, good. Now we reach SC. They have told us that 2SC is the same as A to B. So meaning, we know that 2 is just the number, meaning you can easily remove it in a vector. So I can divide this side by 2. I divide this side by 2. These 2 and the 2 cancels. I remain with my A to C equaling AB out of 2. Is this the same as writing 1 out of 2 AB? Is everyone happy with that?
Yes, sir.
Yes.
Then you ask yourself, what is our A to B? Which vector do you get?
B minus A.
B minus A. Very good. So this is our A to C. And in vectors, you are going to discover it that always your previous answer is going to be needed in the next step. Meaning, if at all you fail this part, the other part is going to be hard for you. Should we continue?
Yes, sir.
Yes.
Okay. Then the next part is at C, O to C. O, C. So I want still here, I want always when we are covering vectors that you learn how to come up with those things, not to rely on what you know already. So we want to get O to C. Can someone tell us how can we move from O towards C? I want now the parts. Monica, your question is going to be answered in this part. O to C. Yes, a la persuasion. O to C.
O A S.
O to A.
I think it is
plus A to
O
C.
to A, then A to C.
O to A plus A to C. But I have another person telling us another answer. Someone can tell us, what do you think? Another route. We have very many routes when you are coming to campus. OB
plus BC.
Plus BC. Good. So for whatever route you are going to use, you are going to get the same answer. But what do I want you to discover now? I want you to come back here. You have 2SC is equal to AB. I want us to divide something. What does it mean? It means that when I divide, let me divide this side by AB. I divide this side by AB. I want to get a ratio. This AB and the AB cancels. I remain with 1. So this side I'm going to have 2AB out of, SC out of AB. I can remove these 2. I divide by 2. I divide by 2. So I get A to C out of A to B is equal to 1 out of 2. Is everyone happy with that step?
No.
Yes? No?
No.
Not yet. Not yet. There is something we are going to use what we call the ratios. So that's where I'm going. I repeat. I have 2SC is equal to AB. Are we together? Yes?
Yes.
So I can divide this side. Let me divide by SC. I divide by SC. So this and this cancels. So I remain with 2 equals to AB out of AC. Is that one fine?
Yes.
But do you know that if at all this is a fraction, do you know that anything divided by 1 is the same thing?
Yes.
Is this fine now also?
Yes.
So now, in ratio form, I can write A to B to A to C is the same as, now I go this side, is the same as 2 to 1. Are you seeing that?
Yeah.
Yes?
Yes.
What does it mean? It means, now this is why I want you to understand. Here you need to understand a lot. Now, what does it mean? It means that from A to B, we have 2 parts. And from A to C, you have 1 part. Is that fine?
Yes, teacher.
So in case you have, let me say, in case you have a donut, it means that your donut has 2 parts. So A to B, it has 2 parts, meaning that A to C is 1 part. A to C has 1 part. And since the whole line here is 2 parts, how many parts do we have from C to B?
2. We have 2.
Listen. A to C, you have 1 part. A to C, we have this 1 part. I've put it there. But the whole line from A to B has 2 parts. So how many parts are remaining from C to B?
So 1.
It is 1. Now you're understanding. Okay, now let me first come back here. Do we have O to A? O to A is what?
Yes.
A plus A to C, we have it already got, is what? A half into B minus what?
Yes, A.
So I can continue. Okay, our time is running out, but let me use some more 3 minutes. Okay, so when I come here, I can reduce, you can reduce this. I can reduce and I say, this is the same as A plus, I open brackets, a half B minus a half of A. So what will I have? I have A, I can correct, minus a half A, then plus a half of B. So when you have 1 minus a half, what do you get?
A half.
A half. So what is A minus a half A?
A half A.
A half. So I have a half A plus a half of B. So this is your answer. So those who want, you can factorize out the half and write a half into A plus B. Is that fine? Is that fine? Yes?
Yes.
Okay. 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 So those who wanted to use this route, you have your OB as B, then plus B to C. B to C has 1 part. So it's the same as 1 out of 2 of the line BA. But this one, allow me that we shall be starting from there. I want to keep time for the next lesson. Should we say that we end here? But can you take a screenshot and we try this one at least? Take a screenshot. Are you done?
Yes.
Let me swear. Yes. Okay. I have another beautiful number here. Also take it. Finished?
Yeah.
Okay, good. Okay, so I'm expecting you have an hour now. You have an hour. Can you sit down and just try out those numbers? And then you send in my chat. Send in on WhatsApp to show me how far you have gone. So we shall be ending here. So tomorrow we shall have Let me first stop this recording.